Are we alone in the universe? For decades, scientists have pondered this million-dollar question, analyzing the countless planets of our galaxy that should be brimming with life. But we still haven't found any extraterrestrials, not even unicellular bacteria. This is the Fermi paradox. If you haven't already checked it out, you can watch part 1 of the series, which primarily focuses on what the Fermi paradox is and some potential solutions. So what in our universe is preventing life from reaching a reasonably advanced level of complexity? What is the roadblock that stops our universe from being teeming with life? This single difficulty that is extremely difficult for the vast majority of life to overcome is commonly known as the Great Filter. Perhaps this filter is extremely difficult to overcome, and the vast majority of life is wiped out by it. Or, however, we simply are early. Despite the fact that many planets have existed for considerably longer than ours, we are one of the earlier planets to the game, compared to the countless planets that will form later in the history of the galaxy. But assuming there is a filter that is extremely difficult to overcome, what would it be? Many state that it would be something occurring in the future, something inevitable for essentially all intelligent life. Perhaps editing the composition of your atmosphere unnaturally could destroy all the civilizations who do so, or artificial intelligence takes over, or some sort of super disease wipes everyone out. Yet this seems improbable because of the fact that an extraterrestrial intelligence would most likely have a completely different evolutionary journey, making it think in ways that we could not fathom. If you'd like to see us dig deeper into the probability of discovering intelligent life, what the life would be like, and whether it is a good idea to even contact aliens, check out part 2 of the series. So, if the Great Filter that most life doesn't overcome most likely isn't ahead of us, it would be behind us. But which big steps in the evolution of life on Earth were extremely difficult to take? One of the primary steps is abiogenesis, the rise of living things from dead matter, essentially the origins of life. This is an extremely debated topic because of the fact that very little is known about the appropriate conditions for life to arise. Certain scientists state that the Earth may be the sole planet that has developed life in the first place, ever. Others, however, argue that any planet that has suitable conditions will have microbial life, and the filter may come later. The origins of life, however, can be split up into 3 main steps, the first being self-replicating information from organic molecules, the second one being protocells, and the third being the formation of true cells. We'll make an individual video about this another time. This development of unicellular life happened extremely quickly, and each of these steps could be a potential filter. But combined, they happened faster than all the other steps individually. These included more complex unicellular life that had more energy, multicellular life, and intelligence. According to this, the galaxy should be teeming with basic prokaryotic life. Plus, the genesis of life didn't necessarily have to happen independently on every planet. In fact, basic bacterial life could have been circulating around the galaxy on asteroids for a while, cryopreserved in a frozen state. All it would take would be a single case of the origins of life, and countless other planets would be brimming with organisms. Mars and Venus may have even had life back when they were both water worlds. This idea of life being exchanged between planets is known as panspermia. We could most definitely prove that the creation of life in the first place isn't the filter by finding samples on our next door neighbor, Mars. Stromatolite fossils of ancient cyanobacteria found on Mars would prove that the genesis of life is not the filter we're looking for. Perhaps the indicator we are looking for is the fact that unicellular organisms took an extremely long time, approximately 1.5 billion years, to take the next step, which was being more complex cells with new structures. Initially, the more basic cells, known as prokaryotes, had very little energy or ATP to work with and couldn't form complex structures. However, in an extraordinary event, a predatory cell consumed another one, and the small one began making energy for it. This was the first mitochondrion. We explore this in depth in another video that you can check out. This opened the door to countless possibilities, letting cells have organelles, which are like cell organs. However, It happened in one unlikely event that took billions of years to occur. So perhaps this is what we are looking for. Multicellular life, the next step, happened promptly after, with specialized groups of cells eventually becoming one organism. This happened independently dozens of times all over the world. Lastly, intelligence is the final step. However, other organisms have evolved intelligence. Chimpanzees and dolphins, and octopi who did it independently. So the single most difficult step for life to take is most likely the increase in complexity of cells. This eternally unlikely event, however, paved the road for the extraordinarily complex life that lives upon our Earth. Thank you so much for watching, and if you enjoyed, be sure to like, subscribe, and comment down below. What do you think was the great filter? Vote in the poll above. And also, check out all our social media accounts on Instagram, Twitter, and Facebook. Lastly, if you enjoyed this content, you'll probably enjoy part 1 and 2 of the series. And of course, always dig deeper.